Welcome to Dr. Yap Banha's Problem Box. In today's lesson, we are going to solve a problem. Let's see what problem we have for today. The problem I've taken from Dr. Yap Banha's Problem Box is this. That's our problem for today. Who is in the problem? A bunch of boys and girls. What is it all about? Well, it is about some of them leaving the event, and then we are asked how many boys were at the event at first. I wonder what we can do. I wonder what method we can use. There were equal number of boys and girls at an event. After some of the boys and some of the girls left, there was still a bunch of children at the event. Can you imagine that? And the question is, how many boys were at the event at first? Can you try to solve the problem? Have you managed to solve the problem? How far have you gone in trying to solve the problem? One of the possible methods is to use bar models. Can we draw bar models for the number of boys and girls at the event? At first, there were equal number of boys and girls. So I suppose I can draw the number of boys and the number of girls. I do know that the numbers are equal. Is this bar models correct? And then we know that some of them, half of the boys, left the event. Can you imagine which part of the bar model we need to shade to represent the number of boys who left the event? And we know that 3/5 of the girls also left the event. Can you imagine what we can do to the bar model for the number of girls? And which portions we can shade to show the 3/5 that left the event? And as a result, there were 315 children who remained at the event. Can you continue? So what's the answer? Did you manage to get an answer? I wonder how I can continue with my bar models to get an answer. There were equal number of boys and girls at first. Some of them, half of the boys, left the event. And some of the girls, 3/5 of the girls, also left the event. And as a result, 315 children remain. So this, together with that, is 315. The problem is the parts are not equal. Fortunately, I know that 1/2 is also 5/10 and 2/5 is equal to 4/10. In other words, all those are actually 9 units. 9 units equals to 315. And if 9 units equals to 315, it is not difficult to calculate the value of 1 unit by dividing, and that will give us 35. What does a 35 represent in this problem? It's one of those units, isn't it? What's our question? How many boys were there at the event at first? Which is really just 10 of those units. 5 here and another 5 here. And to find 10 units is not difficult. To do the calculation to get an answer of 350 and write a sentence to answer the question. At first, there were 350 boys at the event. That's the answer. If you find today's problem easy, you can challenge yourself. How can we challenge ourselves? We can challenge ourselves by, for example, changing something in the story. In the original story, there were equal number of boys and girls. What if there were more girls than boys? What if there were 225 more girls than boys? Why don't you try that new version of the problem? That's one way we can challenge ourselves. How else can we challenge ourselves? If you can manage that version of the problem where there were 225 more girls than boys at the event, what if I change one more information? In the third problem, we no longer know the number of children who remain behind. In the original version, we know that there were 315 children remain at the event after half the boys and 3/5 of the girls left the event. In the third version of the problem, all we know is that after half of the boys and 3/5 of the girls left the event, the number of boys and girls were equal. That's another way we can challenge ourselves. Why don't you try to give those two new versions of the original problem a go if you find today's lesson easy? See you in another problem box.
I can't forget the day we met. Your eyes so blue, me piercing through. I can't forget the day we met. Your smile so bright, it made me swoon. Our love is like a